In this video, I want to look at some examples of some more advanced surface area problems. We have a hexagonal prism here, and then we have a pentagonal prism, and I want to look at how to find their surface areas. So let's look at the hexagonal prism first. The lateral area, assuming that that's a regular hexagon, which we have to know to be able to do this problem, assuming it's a regular hexagon, the lateral area for these problems is going to be very, very simple. Okay, so we can see here each of these side lengths is 4, the height is 5. So each of the rectangles that goes around the outside would be a 4 by 5. Okay, so each of those rectangles has an area of 20. If you count, there should be 6 of those rectangles as you go around the outside with the hexagon. So 6 times 20 would be equal to, oops, 6 times 20 is equal to 120 square units, okay? So that would be the lateral area of that hexagonal prism. Now the follow-up here, I need to find the area of the bases, okay, if I'm going to find the total surface area. All right, to find the total surface area here, we're going to have to add the area of the hexagon. Remember that hexagons break up into equilateral triangles, okay? So you could find the area of one of these little equilateral triangles, and then you could multiply it by 6. Remember, the area of an equilateral triangle is s squared over 4 radical 3. We get that nice little formula from the previous chapter. So in this particular case, 4 squared is 16. 16 divided by 4 is 4. Each equilateral triangle inside that hexagon is going to have an area of 4 radical 3. Okay? Of course, it's going to break up into 6 triangles, so we can take 6 times 4 radical 3. The area of one hexagon with side lengths of 4 is going to be 24 radical 3. Okay? Now you have to be careful. You got a hexagon base, and you have a second hexagon base. So we're going to multiply that 24 radical 3 by 2, and we're going to get 48 radical 3. Okay, so we have the area of the sides, which is 120. We're going to add the 2 bases, and notice those are not like terms. Okay, so I can't combine those together and get 168 radical 3. I've got 121s. I've got 48 square roots of 3. We're just done with that at this point. Good idea to put square units on there if they didn't give you units in the problem, but that's the basic idea. Let's transition over to the pentagon. Okay, part of the pentagon, not too hard. Part of the pentagon, pretty tricky. Look at what's going on here. So if I want to find the lateral area of the pentagon, again, assuming it's regular, and you'll notice I've got the same dimensions here. Same kind of thing. Each of the faces is a 4 by 5 rectangle. Okay, so we have 5 faces, each of which measures 20 square units. It's 100 square units of lateral area. Okay, piece of cake. Remember that pentagons, octagons, decagons, dodecagons, pentadecagons work a little bit differently than some of the other kinds of shapes we've worked with, okay? They do not break up into equilateral triangles, all right? So if I have a pentagon, I'm going to blow this up here just a little bit so you can see it really well. If I have a pentagon with side lengths of 4, you could break this up into triangles. They just aren't equilateral triangles. I'm going to go over to the Apothem formula. 1/2 the Apothem times the perimeter. Okay, we put together that relatively simple formula. And so I want to find the area of one regular pentagon. Well, the perimeter is pretty easy, right? Because I've got 5 sides, each of which has a length of 4. Okay, so the perimeter here, 5 times 4 is equal to 20. Not a lot of work. All right. The apothem. Remember the apothem. If you were going to make a triangle here, and you don't have to use this formula, you could find the area of a triangle, but if you're going to put a triangle here, to find its area, you would need its height, okay? And the height would go from the center of the pentagon to the midpoint of the side. That's the apothem, okay? I'll label that there with an A. So we have a little triangle here. If that whole length is 4, this little half length there is 2 in that right triangle. That is not a 120-degree angle, which means if you divide it by 2, you're not going to get a 60-degree angle, which means it's not an equilateral triangle, okay? So just a reminder, the sum of the exterior angles is 360 degrees. There are 5 exterior angles if we extend to one side. That means that you have a 72-degree angle on the outside here. 180 minus 72 is 108, okay? These are 108-degree angles. Again, if you haven't memorized that pentagons have 108-degree angles, hexagons have 120-degree angles, octagons have 135-degree angles, I would highly encourage you to memorize those. You need to know that, okay? That's pretty basic geometric knowledge. But if you have to, you can figure that out again, okay? Or you could also use number of sides minus 2 times 180, and you can find out that the angle sum is 540 degrees, which you also should have memorized. Divide by 540 by 5 and figure out that you have 108-degree angles. Anyway, long story short, what you've really got here is a triangle with an angle measure. Be careful, it's half the 108-degree measure. So that's a 54-degree angle, and then there's a 54 on the other side. Okay, so what we have here is a right triangle with a 54-degree angle. You've got a side length of 2, make sure you're using 2 and not the 4, and then you're trying to find an apothem, all right? If you think about your SOHCAHTOA rules, we have an opposite leg and we have an adjacent leg. That's a tangent, okay? So tangent of 54 is equal to the opposite side over the adjacent side, that's a over 2, okay? To solve for a, to solve for the apothem, we can multiply both sides by 2. And so in your calculator, you're going to be putting in twice the tangent of 54. If I take twice the tangent of 54, make sure you're in degree mode, by the way. So 2 times the tangent of 54, I get about 2.753, okay? So A is about 2.75, we'll say 28, okay? And that's the value that we're going to put into the equation. So half of 2.7528. And actually, if you can leave that in your calculator, that's even better. So I'm going to divide my apothem by 2. And I'm going to multiply by the perimeter of 20. And my area of one pentagon is about 27.528 square units. Okay? We've got a bottom pentagon. We've got a top pentagon. So you're going to have to double that. And that's about 55.055, okay? We're going to be adding that to the 100 that we had originally, okay? So the total surface area here should be about 155.06, we'll say, square units, all right? So be careful. If you have a base that's an octagon, pentagon, heptagon, decagon, anything that's not a hexagon or an equilateral triangle, if it's some kind of a regular polygon, make sure you're finding angle measures, make sure you're using trig to find the areas. A little bit more challenging.